For any real numbers, square root of a and square root of b, to multiply square roots, we simply multiply the radicands and take the square root. Let's illustrate this property for the product rule for square roots. Here we have two radicals multiplied together. The rule says multiply the radicands together and then take the square root of that product. 3 times 7 is 21, and so we have a simplification here of the square root of 21. Look at this next example. Here we have two radicals multiplied together. We'll multiply the radicands underneath one radical sign, which is 11 times 11, 121, and then simplifying, since this is a perfect square and we can see this, we may have gone directly to the answer of 11, but we've shown here the steps that verify that in fact the answer is 11. We could also use the product rule. Even though it's not an integer, here we have rational expressions as our radicands. We still will multiply each radicand underneath a single radical sign. There's nothing to cancel out, so our result of multiplying two rational expressions, the numerator will be the product of the two numerators, which in this case is 10, and our denominator will be the product of the denominators, or 21. And here we have our simplified version of this multiplication of radical expressions. Let's take a look at one more. No different. The product rule for square roots says multiply the radicands together. And simplifying, if we multiply our integers, we have 15 times the product AB. Note that we make an assumption that the square root of both of these radicals is a real number, and to do that we must have that both A and B are greater than or equal to 0.